Greetings, the Astro 30 here yet again, and welcome back to AEL. I've got this subwoofer amplifier to look at today. I really should be working on other things, but yeah, I just can't be bothered. This is my flatmate's. He got it from the Glenorchy tip shop on the weekend, and the box cabinet this goes in is actually downstairs. It's a fairly large 12-inch cabinet. Well, it's got a 12-inch driver in it. This is an Australian brand apparently. It's a Sonique Audio Pty Limited, PO Box 1225, Elizabeth Bow, South Australia, 5112. And it's a Thunderbox 1200. The reason I'm laughing about this model number is, unless you're Australian, you're not going to understand that reference, but in Australia, Thunderbox is the colloquialism for a toilet or an outback dunny. We call them Thunderboxes. Same as those porta potties that they have at building sites. They're often referred to as Thunderboxes. That's why I'm laughing, and that's great, Sonic. That's wonderful that you named it that. It gave me a real good laugh there. I have looked online quickly and I cannot find a schematic for this. Obviously not. And yeah, they cut the cord off and marked it parts only because, well, it doesn't work. Well, they can't get it to work, whichever. So I've just bodged in a power cord here. It's just for testing. I do have another power cord to put on this, but we'll turn it over. Changing the power cord might be a bit awkward though, because of all this circuit glue crap around everything. So getting that clamp out to change the cord might be very difficult. It also goes into some wire nuts as well, so that's going to be fun to mess with. Up here is the power amplifier, and conveniently this plug here, which goes to the input board, rear board, they've marked along the connector what the what's what, so I can see where the signal is, which is the first wire here at pin 1, I believe that is, and the ground, signal ground, plus 12 volts, ground, minus 12 volts, and a mute. So power comes off the transformer secondary into here. There's no switching, so this amplifier, when it's plugged in and turned on at the wall, is live all the time, which, yeah, over time is not good for the amplifier. It can start burning things out, and it's probably more likely the fault with this is the power amplifier. Now, I've been through and checked all the components, apart from the capacitors, resistors, diodes, transistors, and everything. Everything's fine. There's no open components, there's no shorted transistors or anything like that. So what I'm going to do is I'm going to plug it into the dim bulb and let it power on, and we'll see what we've got at the output terminals, and we'll also check to see if we've got the plus and minus 12 volts on this connector, and yeah, we'll just see what's actually going on with it. Okay, dim bulb is just off to my left. I'll just get my multimeter ready. I'll turn the supply on, and it did brighten up there for a second and dim out, and it's only just glowing dimly, so there's no issue like a shorted output stage, which is good. I've got to be careful of this AC mains cord because it's right near my right hand. So here's the output, which we do not want to short together. So I'll just turn my multimeter on to voltage DC, and thought I could smell something there for a second. Nothing appears to be getting hot though, so that's good. Right, so I'll grab my positive lead, shove that in the positive terminal, grab the negative lead, shove that in the negative terminal, and well, we've got a bit of DC offset there. It's about 800 millivolts, but it is dropping off. When I tested this initially, it was more like closer to 1.5 volts, but it seems to be okay, I guess, but it is awfully high. So just put these wires to the side, hopefully they don't short against each other. So I want to go between ground and this one here. Apparently -3 volts, that should be +12, that's wrong. Am I in the right spot? Yeah, so -12 should be this second pin. Right, that's saying -11, so that one's right. That one's saying -3, so that's not right. So the regulation circuitry is over here, so one of these, that's the high side coming in. Okay, so we're getting, yes. Right, there's 11 volts at the collector of one transistor, it's a series pass. And there's the negative 12 volts. It's just not at the connector properly for whatever reason. Okay, so that's an issue. So let's see what the output's doing again, just to verify things. If I can get the thing to connect. Yeah, it's dropped to about 650 millivolts. Alright, so I'll turn that off. What I'm going to do is I'm going to unplug this connector, if I so can, just to see if that affects our output in any way, shape or form. These capacitors filters have bleed resistors on them, so that's fine. It should not cause any issues like sparks when I'm sticking a screwdriver in here. This circuit glue is so annoying, and that's how you end up damaging these JST connectors. There we go, that's disconnected now, so there's no connection between the front and the rear. Dim bulb on. Output voltage is now closer to a volt. Okay, so that made no difference. So there is definitely an issue with the power amp. So with the connector disconnected, yeah, there's only 1 volt at +12, so the front board's not going to work either. But the negative is getting there, so there's an issue around this connector somewhere, which may be causing an issue with the output of the power amp as well, because I find that I'm getting the same voltage between ground and +12, yeah, about 1.2 volt, as I am on the output. So, or close to it. So there's definitely some form of issue going on here. So what I want to do is turn that off. Is I want to like pull this board out and turn it over. I think I can make it easier just by unscrewing the heatsink and flipping it over rather than take the heatsink off of the board, or the board off the heatsink, and just go and have an investigation on the underside, because if there's no +12 volt at this pin where it should be, but there is, you know, the voltages where they should be over here at the series pass regulator circuitry, then there's an issue with continuity somewhere here. So I'll get to doing that. Okay, well, I've got the power amplifier away from the chassis and turned it over and moved the chassis to the side. And I can't see anything obvious. There is quite a bit of heat damage around these traces and pads and stuff just up here. But that doesn't explain why the negative, well, the positive 12 volts has disappeared, which is this pin here, because that should be, this is a single-sided board, so this should be routed back to one of these transistor circuits here. So I'm not exactly sure why the negative is missing, sorry, the positive is missing. Yeah, because we got the negative side, we haven't got the positive. So what I have to find out is, well, where things go to. So if that's positive there, so it's positive there, that should go, there's a route there which goes to there, which goes over to this capacitor's positive, which goes to that transistor's, I'm assuming that's the emitter. So maybe, yeah, okay. That joint looks cracked, actually. I can't zoom in any further, but that joint here on that emitter has got a little bit of cracking going around there. So if the positive comes off with that pin, but it's not making it to there, then yeah, that would make sense. As to why I was measuring at the collector, which is most likely, well, I assume it's the collector, but it may actually be the base of the transistor. So I'm actually measuring at the Zener diode, which is here, which goes to that center pin here. So that would be the base, okay, and that would be the either the collector or the emitter, depending on what this transistor is. So I'm going to reflow that joint for a start and see if our positive rail comes back. That one doesn't look much better, but we do have negative. I'll also go through and check some of these joints over this other side here are also looking pretty concave and not connected properly. That one especially. So I might go through and reflow all these joints just to see if that makes a difference. Because, well, I didn't actually check to see whether or not we had good continuity between that socket connection and that emitter. So I'll just touch it on the edge of the component. Well, apparently we do. So I'll turn him over. And that's one is there, should go to, is it there or there? Well, it says we've got continuity, but we don't have voltage. So, okay, I'll go reflow some stuff. Well, I've reflowed some joints on the main PCB here, and I'm about ready to test to see whether or not we've got our voltage back at the positive. Can you see that? Yeah, sort of. Okay, so, and I've cleaned as much of this circuit glue crap off as I can. So turn on the dim bulb, nothing unusual. so there's no shorts or anything, which is good. I might make it easier on myself and jam my negative multimeter probe into the negative speaker terminal, just so I can have a free hand. I've got minus 11 volts there at the minus 12, ground's there, and apparently we've only got 2 volt there, which is not right. Let's just measure at the ground point and the positive. Well, interestingly, we do not have the voltage coming out of that transistor properly. Got the minus coming out, but not the positive. And at the speaker connections, we have 900 millivolts, so we've made no improvement. So this is going to turn into a complete nightmare. So I'll just double check with a different ground. I'll use the signal ground instead. Yeah, there's definitely no voltage coming out of that pin. Well, 2 volts. So there's something wrong with this transistor circuit here. And I'm going to assume that that capacitor comes off of that emitter, which it does, but we've got the 12 volt DC there now, but not there. Does that come off of there though? That's the question. I don't know. There's 3 volts there, 2 volt there, so which capacitor connects where? That's the question. So I'll turn that off. Oh, that's the base capacitor, right. That's probably the emitter one, which it is. So that's a 220 16 volt. I don't have any. So I think it's pointing to maybe we've got a dried out capacitor. That could be holding this down. The transistor itself does function, as far as I'm aware. That is an DJ something. Oops. That is a either an S8050 or a DJ331, whichever. No idea. So if the base is there and the emitter's there, so we know that this is going to be on the positive, so that should be a PNP. So base is there, or at least we assume it is, unless it's an NPN. That's interesting. Got a diode junction there. Nothing there. And definitely nothing there. Well, that's interesting. We've got no junction. I mean, am I measuring this correctly? Who knows? Well, okay. I've got no diode junction, because this would be base, because that's going to a diode, yeah. So that would have to be the base of the transistor. So that would make that either its collector or emitter. Nothing's happening there. Okay, so it looks like this transistor is actually open collector to emitter, or collector to, sorry, base to emitter, or base to collector, whichever one that pin is, because I can't get a reading either way around. Okay, that's Q120. Right, so this little bugger here is an S8050 and it's an NPN transistor. And it is definitely base in the center, emitter on the left, and collector on the right. So we have got no NPN, we've got no junction at base to emitter. So the emitter is open, or base emitter junction is open, which would be why we don't have the minus 12 volt, sorry, the plus 12 volt. I keep getting things wrong today. So that transistor is definitely dead. So I've got to figure out what an equivalent replacement is for that, because I don't have that one. Okay, apparently you can substitute it for a 2N3904, which would have the same pin out. I don't have any of them. Or a BC547. But you'd have to reverse the transistor around, because it goes collector, base, emitter in that order, so it'd be the wrong way around if you put it in as it is now. So I might swap that out for a BC547. It couldn't hurt. And yeah, we'll see if we get a plus 12 volt rail back. I don't see that we're going to get, you know, any output still, but if this regulator circuit's not working, then the front panel board's not going to work either, and you're not going to get any signal through to here. Okay, the transistor's been replaced, and when I measured this one out of circuit, the emitter junction's about 0.9 volt between that and base, which doesn't seem right to me. The thing is turned on. The transistor is not getting hot in any way. I wish there was a more convenient ground point here, but there isn't. So if I measure between ground and the emitter of the transistor, we have 11 volts DC there. Isn't that special? Right, I'll turn that off and I'll reconnect the front panel and turn it back on again. No issue. So we go between ground and here, got 10 volt, ground and there, we've got our negative 11. So we have power going to the front panel, or rear panel, and I'll just measure across our output, which probably hasn't made a difference. Well, actually, yes it has, look at that. We've got bugger all DC offset. This looks like it's safe to connect to a load, an oscilloscope, and input source, and see if we actually have a working amplifier now. And then I can turn my attention to replacing the cord. So let me set this up properly so we can hook it up to some test equipment, and we'll see what it does. If that's all it was just one transistor causing a whole series of issues, well, actually that would make sense depending on the design of this amplifier. If this positive 12 volt rail is actually used somewhere else around the power amp, then yeah, it's not going to allow the amplifier to work correctly, and that hence why we had that high DC offset. So, okay, all well and good. Don't have to replace any components except a transistor at the moment. I've only got 2 screws holding this heatsink in, but that'll do for now. So yeah, I'll get the test equipment set up, oscilloscope, dummy load, etc., and I'll inject a signal. So with this I want to make sure that our level's maxed out, crossover we'll set at half, level at half. I'll stick some input into here. I mean, these sockets are all over the place, but whatever. And yeah, we'll see if we have an output. Right, got it hooked up to the dummy load, and I've got the signal generator going into the input. It's turned on. We've actually got a green power light now. and if I turn it to off it goes red and then disappears. And the power light went red. So if I put it to off, nothing much happens there. Put it to auto, it remains red. Turn it on, it goes green. Anyhow, it's hooked up to the scope, so I'm just going to wind my DDS volume up. We have an output and it's clean, and that's the auto circuitry messing around. I think the dim bulb might be affecting it a bit too. Yeah, it's trying to draw too much power, so I'll turn it down. There we go, it's stable there. The dim bulb's limiting the current too much, but it is working. Isn't that great? So if I twiddle the level control here, it increases, decreases. Crossover. Oh yeah. Look at that. That is perfect. So with that running now, I'm just going to double check heat wise. Nothing's getting hot. That transistor I replaced wherever it's gone. There. Nah, cool as a cucumber. Excellent. So what I might do now is, apart from turn it off, is I might actually go about replacing this stupid line cord, which is going to be fun. Now I don't have any of these wire nut connections that they're using. These stupid things here, and that's how they're attaching the cord and this filter capacitor. So what I might do is I might cut that cable tie off for a start so I can see what's underneath it and where everything goes. And I might just simply solder the wires together and put heat shrink over it. So what have we got here? We've got, that's the active coming into the transformer. So that's coming off of the line cord. So it's not fused through the active, it's fused through the neutral. Of course it is. Which means with the neutral connection, yeah, I only have to remove the heat shrink off of the fuse holder and this one wire nut, and actually, well, it's a crimp nut actually, and just solder the wire directly with some heat shrink on top of it, and that should be good to go. So I'm going to mess around and try and get this bloody clamp undone from the glue, and then we will come back and test it again with a new line cord, and then I'm pretty sure it's safe to plug into the wall, and then we'll do a full power test on it. Right, new line cord is patched in. Now I made an executive decision, rather than mess around with the fuse socket heat shrink and have to like pull all the wiring out and redo it, I just tapped into the original wires and put a piece of heat shrink over the top, and they're soldered underneath. It makes the connection, and I've checked across the plug. We've got continuity about 10 ohms to the transformer's primary. We're not shorted to the earth pin anywhere, so this should be good to plug in and test. I ended up replacing the clamp too because it wasn't gripping very well into the hole. In we go. Excellent. No smoke. Everything looks good. So now what I should do is probably turn the unit back over so I can plug the audio connector back in. And we still have an output, which is excellent. Okay, so what I'm going to do now is I'm going to take it off the dim bulb. I'm going to plug it directly into the wall and do a power test on this, and then I will re-tidy up the cables, and that'll be it for it. Alright, it's plugged directly into the wall and there's no issue, so I'll turn up the DDS. Oh, look at that. Okay, so I need to change my volts per division. Ooh, holy shit. I can really hear that transformer screaming. There's clipping there. 27.3 volt RMS. Not too shabby, that's 93 watts approximately RMS. That's perfect. Cool. So I guess the next thing to do is to actually put it into a speaker driver. I don't have the subwoofer up here, but I'll just put it into a test speaker for testing purposes only. And we'll see if we get a sound output that's clean. It'll be 100 Hertz, but that's fine. Alright, test speaker is hooked up. It's only a little TAC thing. I'm not going to be driving it too hard anyway. Hardly any turn on thump, which is interesting. Well, crackling and popping going on. That could be anything though, but it is functioning. So let me change the frequency to a lower one, like 60 Hertz. Yeah, it's got a bit of hissing and popping going on. Yeah, okay, it's got some noise. That's kind of depressing. That means we've probably got some more bad joints or another transistor on its way out. Well, the thing is, I have got it back from the dead, so that's alright, I guess. So I'm going to call that a win for now. As for all the noise, well, I may have to investigate this. Jesus. Okay. I may have to investigate that a little bit further. Yeah, that could be anything. But yeah, anyway, I'm going to end this video here because the main purpose was to find out what the fault was originally. I've done that. And now I've just got to figure out where all that popping sound is coming from. So anyway, if you enjoyed this video, please go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying, see ya. I'll catch you in the next video. Thanks for watching. Snap, crackle and pop.